and subtracting. Rational expressions. Rational expressions are, we talked about this, fractions. They're just fractions, but they're algebraic fractions. Okay? So let's start with, before we get to algebraic. Algebraic means add letters, right? Let's do a couple of them to remind ourselves how we first learned it, how we've been adding and subtracting just regular fractions. What's the first thing you need when you add or subtract fractions? Anytime you're adding or subtracting any fractions, what's the first thing that you need? Starts with a C. Common denominators, right? Common denominators. Common denominators mean they're both the same, all right? So right now on the first one, I have a 15 and I have a 5, right? The denominator. They have to be the same. Well, how do we make them the same? We try to find the smallest thing that both 15 and 5 will fit into, okay? A lot of you can do this in your head, but I'm going to do it a little differently because it's going to help you later today. So the way we do that is by breaking down the denominator. First step, factor all the denominators. We have 2. Break them down. These are monomials. So we break them down using the tree, right? So 15 becomes 5 times 3, right? That's as far as we can break it down. 5 is just 5, or 5 times 1, right? Okay, that's the first step. Second step, what is missing? So they both got to be the same, right? To be common denominators, they both have to be the same, equality. So is this guy missing anything that the other guy doesn't have? Is this guy missing anything that the other guy has? No, it's got everything, right? This guy's only got a 5. This guy has a 5 and then some. This guy's missing something though, right? He's missing a times 3. So what we do is we put a times 3 here. But whatever, when it's a fraction, whatever we do to the bottom, we also have to do to the top as well. Okay, so if I multiply the bottom by 3, I have to multiply the top by 3. So now the denominators are the same. They're equal. 5 times 3, 15. Okay, so this one is 15. The 4 just stays 4 because I didn't need to multiply because I didn't need to include anything. It already had everything. The bottom, this one becomes 15 and the top becomes 3 because 1 times 3 makes 3. Okay, that's step 2. Step 3, add or subtract. We only add or subtract the tops. The bottoms stay the same. 15 stays 15. This one's subtraction. 4 minus 3. 4 minus 3 is 1, so it's subtraction, so I get 1. And then the last step, reduce it if you can. Well, I can't because 1's already broken down as far as you can. So you're done. Okay, that's the steps we're going to use. That's the steps you used back when you learned how to do this in elementary school and the steps you've been using. I do it a little differently. I do step 1 a little differently. A lot of you guys can do common denominators in your heads. That's great. That's great. But I'm doing it a little differently because it might help you later. Okay? Okay, so let's look at B. Same thing, right? We got denominators that aren't common right now. They are not common. 3 and 7 are not the same. Okay? So break them down. Again, some of you could do this in your head. I know what the common denominator is going to be. That's fine. But I'm just going to show you this method because it'll help you a little bit later, especially when we do part 2, day 2. So 3, break down 3. 3 times 1. 7, 7 times 1. Okay? Step 1 done, broke them down. Step 2, what is missing or what is needed? Well, the first one just has a 3. That's missing a 7. So I need to include a times 7. Same thing up here. And then the second one, to make them equal, is missing a times 3. So now the common denominator is 21, 3 times 7. So then the top becomes 7 for this guy. And over here it becomes 6. Add the tops. 13 over 21. Again, 13 over 21 can't be reduced, so you're done. Okay? So we're going to do the same thing. That's all we're doing. Now, they're going to include X's and Y's and A's and B's, but we're going to do the same steps. Okay? It's all the same. Okay? That's all we're doing today. These are the steps that we're going to do, the steps we've been doing. Okay? Today, all of the denominators will be monomials. I think there's one that's a binomial, but so the binomials and the trinomials we're going to save for next time. Today we're just getting kind of just slowly kind of easing you guys in. Okay, so today might not be that bad. Okay, I did that on purpose. Okay, so denominator. We have one denominator there, one denominator there. So now we're adding x's in there. That makes it a rational expression. Okay, it goes from a fraction to a rational expression. Break them down. Break down the 5. When I break down 5, it just stays 5, right? 5 is just 5 times 1. How do I break down x to the 3rd power? Yep. Done. Broken down. Now I got to do the 2. Break down the 2. Just 2 times 1. So now I ask the question, what's missing and what's needed? Okay. So over here, this guy's got a lot, but it's missing something. What is it missing that the other guy has? So this guy right here, it's got 5x to the 3rd power. It's missing the 2. So we need a times 2 there. So I got to multiply the top by there. The 2 is missing a lot. It's missing a 5, and it's missing an x times x times x, right? Okay, so now, how do I know I'm done? Because the denominators are the same. I have 2 times 5 times x times x times x. Same thing over here. Well, 2 times 5 is 10. X times x times x is x to the 3rd power. So the common denominator is going to be 10x to the 3rd. Okay. What's the top? What's the numerator now? Well, the first one's going to be 2 times 3, which is 6. The second one's going to be 1 times 5, which is 5, x to the 3rd power. Okay. Add or subtract the top. So can I add the tops and make 11? So can I add 6 plus 5 to make 11? No, right? They're not common denominators. They're not like terms, I should say. Not common denominators. They're not like terms. These guys right here are not like terms. So what do I do? Well, I just write them down. I say 6 plus 5x to the 3rd power over 10x to the 3rd power. Here's my question. Can I do this? Giant 1. Can I do that? Everyone okay with that? So when we could do that, it was because they were the same, right? So let's look at the top before I do that. Look at the top. Is the top a binomial, a monomial, binomial, or trinomial? Binomial, right? Is the bottom a monomial? Is the bottom a monomial or binomial? Monomial. So remember, when one's a binomial and one's a monomial, we can't do that. So that's why I cannot do that. If this plus 6 wasn't there, go for it, because then the top's a monomial. But because of that, it's the same rules. So just be careful with those, that you are done. Like we can't even do this. We can't even divide that by 2 and divide that by 2. We can't even do that because The top is a binomial, the bottom is a monomial. We're done. There's nothing we can do. So just be careful with that when reducing. All right. Okay, let's do B. Okay, so we're subtracting two rational expressions. So the first thing we got to do is break down the bottom. So we get 5 times 5 times x times x. This one we just get 5. Okay. Make them equal. Make them the same. Well, this guy's got a lot. Does this guy need anything that the other guy has? So does this guy need anything? Do I need to include anything here? No. The other guy's only got a 5. And this guy's like, you know what? I got 2. I'm good. This guy needs a lot. It needs 3 x's, right? Are they equal yet? Oh, sorry, yep, you're right. It only needs 2. Are they equal now? No, yeah. I had some students say, well, do I have to include another 5 in there? Because they already have a 5. Well, no, it needs 2 5s to be the same. It's got to be the same. Okay? So this guy needs a 5 and 2 x's. Okay, so now the bottoms are exactly the same. 5 times 5 times x times x. 25x squared. That's the common denominator. This numerator didn't change because the denominator had everything. So this guy stays the same. The other one needed to change. So it's 1 times 5 times x times x. 5x squared. Subtract the top, but I can't because one's an x squared and one doesn't have an x squared. So I can't do that. Can I do this? No, because the top is a binomial, yeah. Done. Okay. All right, let's look at the bottom. Let's look at the back. Okay, so this guy has 2 letters now, x and y. It's the same thing, though. It's the same thing. Treat it like if it were numbers. If they were numbers, we'd break them down. Well, they're letters. We'll break them down too. Okay. So the first one is x times x times y times y times y. Next one is x times y. Okay. Step 1 done. Factored them down. Step 2. What's missing? Well, the only thing that's missing is this guy needs 2 y's. 2 more y's. Now they're equal. The first one didn't need anything. It's already got everything. So now what is the common denominator? X squared, y to the 3rd. The first guy stays the same. The second guy is 1 times y times y. Y squared. Denominator stays the same. We just add the top. Here's a question. So my answer. Is the top a monomial, binomial, or trinomial? Binomial. It's got 2 terms, right? What about the bottom? It's a monomial. Yeah, the bottom's actually a monomial. I know it's got an x and a y, but it doesn't have a plus or a minus in between them. And because of that, it's a monomial, right? So that means we can't cancel out those guys. We have to leave it the same. Okay. Okay. Okay, example number 3. 3a. Which are always the easiest fractions to add or subtract? When they what? Fractions are always easy to add and subtract when they already have common denominators, right? We don't have to do anything, just add or subtract the top. Like 1/2 plus 1/2. 1/4 minus 1/4. You know, they already have common denominators, right? Well, we don't have to break down the common denominator because it's already done for us. We can skip step 1. It's already done for us. So the top is negative 3x squared minus negative 4x squared. Those are like terms, x squareds, right? But before I do that, I gotta change because it's minus a negative. So you just get x squared. At the bottom you get 4x plus 9. Top is a monomial, bottom is a binomial. We're done. Okay. Top you subtract a negative. It's not negative 7x squared. I get that mistake a lot. Oh, you got negative and a negative, add them together, you get negative 7. No, if this was plus, you'd be right. But that's a minus, so it's subtracting a negative. So just be careful there. Okay, all right, so what I want you to do is letter B now. Do 3B. 3B on your own. B on your own, and then we'll go over it. So 6x you break down to 3 times 2 times x. 8x, 8 breaks down to 4 times 2, but then you got to break down the 4, so it's 2 times 2 times 2, and then times x. Okay. They're very close, but they are missing some things. The first one needs 2 more 2's. It needs 3 2's total. So 2 times 2 times 7. The second one needs a 3. Didn't have a 3. Okay. So the common denominator now is both the same. Same numbers you're multiplying. 1 3 and 1 3 and 3 2's. So when you multiply 3 times 2 times 2 times 2, you get 24x. Okay, so the top over here, 2 times 2 times 7 is 4 times 7, which is 28. And then over here, 3 times 3 is 9. So the common denominator is 24x. Subtract the top. 28 minus 9 is 19. Now they're both monomials. 19 and 24x are both monomials. So if I can cancel them out, if it's possible, then do it. But 19 is only 19 times 1. 19 is prime. The only way to make 19 is 19 times 1. So it won't. So you're done. Okay. All right. So I want you to do C and D now. C and D on the other side. Do C and D. I want you to try those. Give those a shot. Okay, so I did the first one already. So broke down 4x and 4x squared. The only thing that was missing, the first one needed an x. The green one up here needed an x. The green denominator here just needed an x, so I had to put an x up here. Okay, they were close, but they weren't the same. Top is a binomial. Bottom is a monomial, so I can't reduce or anything like that. Okay. Letter D, letter D. Well, they're just 3 and 9. A lot of you probably can do this in your head. The common denominator between 3 and 9. If not, it's 3. Or sorry, it's 9. So they need, so the second one needs a 9 or a 3. So the common denominator is 9. So you get 4x, and then 7 times 3 is 21. 4x plus 21 over here. Okay. All right, so the bottom one. Last one in your notes. We're going to do a couple more problems in your notes, but this will be the last one on the notes here. Okay, so what's different about this one than the ones we've done in the past? It's got a minus. What's the difference between? What's different about this one than the rest of them that we've done up to this point today? Yeah, the second one's not a fraction, right? XY, it's just XY. Okay, so my question is, how do we make things into fraction? So if it's not a fraction, how do we make them into fraction? What's the rule for making things into a fraction? Yeah, there's always a 1, whether it's a number or whether it's a letter, it's always got a 1 underneath. If it's not a fraction, you can always put a 1 underneath. Okay, and then we're gonna do the same thing. I got 1 as a denominator and x to the third power as a denominator. Okay, so the 1 needs an x to the third power, or sorry, y to the third power. Do I need to put a 1 in front of the y? Do I need to put that there? Doesn't hurt, but you don't need to. Doesn't hurt. 1x. So the common denominator is 1 y to the third. So the first one is x. X times 1 is just x. The second is x times y times y times y, which is y to the fourth. X, y to the fourth. They have common denominators now, so I can subtract the top. X minus x, y to the fourth. Y to the third. So this is where I see some mistakes. This is x minus x. Can I subtract those to make 0? No, because it's not x. This is not x. It's xy to the fourth. It's close, but they're not like terms, so I can't. And then I can't cancel out the y's because top is a binomial, bottom's a monomial. I'm done, as far as I can go. Okay, so I'm going to give you 3. These don't take that long, so I'm going to give you 3 problems to do in your notes, wherever you're going to tape it in, and then we'll be done. Then you'll tape in and you'll be done. Okay, so I'm going to give you 3 problems to try on your own, give you some extra practice, and then we will be done. Okay, so we'll call this 3. F, 3G, and 3H. Okay. Add or subtract them depending on what they say. 3F, 3G, and 3H. Okay, I'll give you some time to do those. Then we'll go over them. All right, so the first one, let's break down the 3, break down the x squared. Then I got to find out what's missing. So over here, I need a 2x's. Oops. And then over here, I need a 3. So add those to the, include those in the top. So the denominator is 3x to the second power. Okay. The numerator is 5x squared and 3. And then add those together. Oops, that's not right. It's supposed to be squared. Okay. Second one. To make them common denominators, that one needs a y. You can put a 1 over here if you want. It doesn't hurt. But this guy needs a y. Okay, so the common denominator is just y. So you have y squared minus 1. Y times y, 1 times 1. So you have y squared minus 1 over y. Top is a binomial, bottom is a monomial. Okay, last one. This guy right here needs another 5 and 2 y's. So I need another 5 and 2 y's. This guy over here just needs a 3 and an x. I think they're the same. 2 5's a 3, and x, and yep. So add up 3 times 5 times 5, you get 15 times 5. Is that 75? Then you get x, y squared. Okay, and then you get 40 y squared, and you get 3x. So you get 40y squared minus 3x over 75x y squared. Here we go. Okay, that's about as hard as they get. On Thursday, we're going to do, now, today we didn't have a lot of the denominators were pretty much all monomials. Thursday, we're going to see some more binomials and trinomials. But step 1 is going to be the same, just break them down. And we know how to break down binomials and trinomials, so it's not anything worse. It's just different. Okay? All right. Okay, so tape that in your notes, and we are done for today. I'll post the notes.